We're here in Schriesheim, Germany, about to go to the Schriesheim mine. As we head east toward this castle, we notice quite a steep change in topography. We wonder what might cause this change in topography. And as we make our way toward the silver mine, let's think, how could prospectors have used this topographic discontinuity as a means of exploration? Let's go! As we keep heading east toward the mine, we come across what is known as an outcrop to the local journey. This is just an example of what we'll be seeing in the mine. As you can see, this bunched up rock is quite altered, pretty brecciated, and really hard to determine that there is actually ore in these hills.
Altered brecciated granite. This is considered a good outcrop on German standards, by German standards. It's also a nice place to park your car, shady spot.
Still heading east, but honestly, I don't know. And sometimes we need to rely on Google Translate to decipher what this is telling us. Finally made it to the Bergwerk Anna Elisabeth Mine here in beautiful Schriesheim. So here we have a map of the mine that we're about to go into, and we can see this schematic diagram is showing the workings, these historic workings, which were carved out by the miners over a few hundred years. Notice the scale bar here. It's only 20 meters, and if we look towards how far down this mine actually goes, it's only on the order of a couple hundred meters at most, and that may seem insignificant compared to some of the modern mines, which can go several thousand feet, tens. But keep in mind that these workings were hand carved and slowly blasted away with minuscule amounts of dynamite over hundreds of years. So this is actually very impressive that they were able to carve out this amount of material in such a period of time. So we move over here, we can see this is what's called the hoist house. And this is where the ventilation shaft is located. So as we look down here, we can see a pool of water, feel some cool air coming up. And so as you suspect, this ventilation shaft is to allow fresh air into the mine so the miners are not breathing poisonous gases. This would also be the point where I'm guessing where they bring up the ore, given that there's a winch there. And in the days, obviously they didn't have a mechanical winch, so this was all hand cranked operation. And you can see that there actually are some ladders here and some buckets, so this is probably a good example of where the central ore extraction point was for this mine.
So that's my colleague Kirby.
Yeah.
There were two processes where they had to separate the silver out. First, you had to melt the country rock, which is the granite here. So they would melt that out using what we call a roast oven. And you'd end up with slag like this. That was the melted rock, country rock. And then you would be left with the lead and silver ore. And they go under the day, they say Glück auf. Glück auf has two meanings. One is, with luck, I'll live through the day and I'll make it outside. But the more important meaning is that I hope we find rich ore today.
Glück auf, and now we shall go in.
The horizontal excavations we call Stollen or adits. Adits or tunnels. Then there's the vertical structures we call Schachts in German, but they're shafts, so it's similar. There's two periods of mining here. The first was in the Middle Ages in 1437 to 1530, and that's what we call the Bleisite for the purpose of the tour. They were exclusively mining the Blei ore, the lead ore, for the silver. So the second period began in the 19th century, around 1779, where they had a second ore called iron vitriol. Iron vitriol is an old geologic word that just means iron sulfide. And the iron sulfide that originally was here was pyrite or marcasite, like fool's gold. Yeah. But because of the geochemistry here, the iron sulfide was really eroded out and it became black and ugly, but it was very useful for making dyes or pen ink, but they also used the material for disinfection, for wounds.
Really?
Yeah. Which was dangerous in itself because it was poison.
Yeah. So how much of this was dug out from the first period of mining?
Well, basically all of what you see, what in the second phase they basically widened things.
They widened things, okay.
Yeah, this is the what we call the air shaft or air tunnel. That was mainly directed for circulation of the air, but all this that we see here, that was all in the Middle Ages. There's a fault that was activated about 35, 50 million years ago that runs parallel to the Rheingraben. The Rheingraben is this big structure like Death Valley.
Yeah.
And so it sank about 10,000 feet. And so when that sank, this rose up. And as it rose up, what was above the granite was rock from the Triassic period and the Permian sandstones. So that was eroded off and it left this area.
That's the fill in the ground.
Yeah, we're actually in the vicinity of an old volcano from the Permian time. Okay, what we just traveled through is what we call a fairbau, or fairbau is another word for shoring.
Okay.
And they always used wood. But here what you can see is it looks like a door frame. They would use pine or spruce because it was a softer wood and easier to break. So when you hear it splitting, you have a chance to run out. We have the day shaft where the miner would go up and down and also carry the erz or the ore or the broken up rock. Here we have the main or the main miner. They call the hower. He was typically the strongest ones because he would have to work 8 hours a day, 6 days a week, just with a hammer and chisel.
That's
Yeah. Miners would usually start working 10 to 12 years old. The reason being their father was a miner, so they have to help work when they were old enough in order to pay for support the family. Here we have either a kid or an old semi-retired person hauling out or with a wheelbarrow and bringing it here to the smelter with a Wren oven. And the main reason why this was the most dangerous job was you're working here in an enclosed place and you're melting the rock to 800 to 900 degrees. So you have two problems. You're creating sulfur dioxide from melting the lead and whatnot, but you're also creating carbon monoxide because you're burning wood to a temperature that is so hot enough that the air is now carbon monoxide. So the iron vitriol is just weathered marcasite or pyrite. And so what they would do is they would carry out the ore and they would pulverize it and they'd put it into this basin. And the basin usually held about 10,000 kilograms of ore. And what they would do is mix it with water to leach out the vitriol. And that process took about 6 months. What they call the Schlegel in Eisen. It's basically a chisel where he would just beat it, but what was important is they used a handle with this thing. In a tough granite, they could only get 1 to 3 centimeters deep in 8 hours, and they'd have 3 shifts. So if they were really lucky, on average, they'd only go 9 centimeters deep. So that was a good day. But what the main problem they had here was lighting. In the Middle Ages, they first used an open lamp. They call them a frosch or a frog. Mm-hmm. And it looks like a frog in repose.
Yeah, I can see that. Yeah.
But it was actually named after an Egyptian lamp, because they found one, it had a frog painted underneath it. And so it was an open oil lamp. What they used was rindetalg. We get a lot of calcification from the carbonic acid from the leaf rotting. So it would just, take out the plage.
Okay.
And they would crystallize here. You get a lot of old Middle Age mines that have a lot of calcite growing on them. Black powder was brought here in the 15th century, but primarily, its exclusive use was for weapons and cannons. So it wasn't used for mining until the first time in 1626 in Slovakia.
Yeah.
So that was the first
yeah.
time. Yeah. So that was the first time they used black powder. Unlike the lead ore following the barite vein, okay, which is typical here, iron sulfide here followed the cracks in the granite, so it was more like a web-like ore deposit, and so they couldn't exactly follow it for any long distance. Yeah. It wasn't until the 18th century that they decided to mine it out.
So we're here in the Rosalia mine in Slovakia. As you can see here, there's a lot of manganese mineralization as well as quartz mineralization in these veins. So when they're searching for gold, which this is an active gold mine, they're looking toward the vein for the gold concentrations, because as the quartz was precipitating, the gold was also coming out at that time. So here we have an example of some of what they're looking at. This is most likely sulfides, but there could be a little bit of gold within this sample. Hi everyone. Well, we made it back from Germany and Slovakia, and we're now here in the e-beam facilities at UT Austin. So today what we're doing is we are starting to set up the electron microprobe. This is an instrument we use to gain chemical data for various minerals within a rock. Unlike other instruments within the facilities, we can get exact compositions. So other instruments, including the scanning electron microscope and the XRD, give us more qualitative input, so imaging, maybe crystalline structure, but the true workhorse of our e-beam facilities is this instrument here, which is something you will be using to analyze samples we collected from Schriesheim mine in Germany.